Simple interest takes an initial investment, sometimes called the principal investment, and increases it by an interest rate R every increment of time, T. This increment of time is usually per year, but could be per month or per quarter or so on. In this case, we'll take T as the time in years. And this is from the point of investment. Let's say, for example, we had an interest rate of 5%. We're going to need to convert this to a decimal. Remember, 5% is 0.05. So then we could form a little expression that lets you work out how much money the investment will be worth after a certain period of time. If we call P the principal investment, or just the initial investment, then we can form an expression. So remember, with simple interest, the important thing is that it doesn't pay interest on the interest that's earned. So say, for example, you had a model where you invested £1,000 and then, for the sake of ease, let's say it has 50% interest. So after 1 year, it was £1,500. The next year, it doesn't pay 50% of 1,500. It only pays 50% of the original 1,000 put in. Okay? So putting that into an actual expression, you would have the initial investment, the principal investment. We're going to add on to that R, and this is our interest rate, remember? So R. We're going to add on to that R times by our principal investment, and then times by the period of time. So obviously, if the period of time was just 1 year, T would be 1, and you wouldn't need the T in this expression. But this is a general expression, and we can make this into an equation like this. So we can say A equals P plus RPT. Or, to make it slightly easier to use, we can factorize this to P times 1 plus RT, where A is the final amount after however many years. It's important to remember here that R is a decimal, not a percentage. So most problems are going to give you a percentage, so it'll say like the interest rate is 10% or 5.2% or something like that. You need to convert that to a decimal. An example of how an investment grows under simple interest can be seen here. So in this case, there was a £1,000 initial investment, and this is with an interest rate of 15%. So you can see after 1 year, it's increased by 15%, which took it to 1,150. Keep paying the same amount every single year, because remember, the interest isn't paid on the interest that's already been earned. Compound interest is somewhat similar to simple interest, but this time you do get paid interest on the interest that's already earned. So for example, if you had an initial investment of £1,000 and you were paid 50% per year, that's a massive interest rate. You wouldn't get that anywhere. But if you're paid 50% per year, after 1 year, well, half of 1,000 is 500, so in total you'd have 1,500. Then with simple interest, you would just keep gaining £500 every year because you're paid on the initial investment. With compound interest, you get paid 50% of whatever is in that account, whether the money is earned from an initial investment or it's earned from the interest already paid. So then the next year would be 50% of £1,500, so that's 750. So in total, we now have 2,250, etc. So you can see how rapidly it grows. So again, if P is our initial investment, R is our interest rate, and T is the period of time, we can form an expression for this. So a general expression for this would be P times by 1 plus R to the power of T, where R is our interest rate as a decimal, not as a percentage. That's really, really important. And then, of course, we can set this equal to A, which is the final amount. So there's an equation now for the compound interest. So, for example, if you wanted to use this for an interest rate of 5% and a period of, let's say, 3 years, then you could do something like this. You could put P here. We don't know what the initial investment is, but it would reduce down to 1 plus R. But remember, this is as a decimal. 5% as a decimal is 0.05, so this becomes 1 plus 0.05 to the power of T, which we know is 3. And again, you can reduce this down slightly to 1.05 to the power of 3 times by p. Okay? And with this, if you put a graph for it, it grows rapidly. You'll notice how this curves up, whereas the previous one was a straight line. So again, with an initial investment of £1,000, the first year is exactly the same. You end up at 1,150. So this is an initial investment of 1,000 and an interest rate of 15% again. Because you're being paid interest on top of what you've already earned in interest, it grows by a different amount and a larger amount in terms of monetary value every month. So it results in this curve where it grows rapidly. Decay in financial terms is called depreciation. The easiest way to imagine this is when you buy a car, it might be worth £30,000, but then after you've done a few thousand miles, it might be worth £20,000. So the value is decreased. That's depreciation. Decay is when an amount is reduced by a percentage of itself every increment of time. So say, for example, the car or a stock portfolio or something like that was worth P at one period of time. Then every time it decreases by a rate of R, so let's say it goes down by 5% every year. So let's label that 5%. Then we can form an expression in terms of T as well, where T is our number of years, and this results in P, our initial investment, times by 1 minus R to the power of T. And again, we can set this equal to the final amount, A, to form an equation. So if you wanted to apply the 5% to this, you can see it's very, very similar to the last one on compound interest. However, this time, it's a subtraction rather than an addition because it's going down in value rather than up. So say, for example, we had £1,000. So this is £1,000. And we want to know the depreciation after 2 years. So T is 2. And we know the rate is 5%. We would sub those in, and you could have 1,000 times by 1 minus R, where R is a decimal, not a percentage. So 1 minus 0.05, because that's 5% as a decimal, to the power of T, where T is 2. Okay? Obviously, you can simplify this down slightly to 1,000 times 0.95 squared. And if you put this in your calculator, you can see how rapidly it depreciates. So after 1 year, of course, it would be £950 if you're losing 5%. But then after 2 years, it would be £902.50. So you can see it really quickly depreciates. Again, you can plot a graph for this, so something like this, where in this case, the initial investment was £5 and it's a depreciation of 15% per year. So each time, you'll notice how it sort of loses less and less each time. 15% is being applied to a smaller value each time. So in terms of monetary value, it actually decreases by a lesser amount. If you found this video useful, why not try the topic test on our learning platform? Here, you can answer a series of questions and get instant feedback on how you've done in a written solution format that explains exactly how you should solve the problem, and also a video solution format if you're still not sure, an expert can talk you through it.